Okay, today we are going to be talking about the last bit of new material before our test. Okay, so try to lock in. This is not hard. You already know how to do this. Today's lesson is called Limiting Reagents.
Wait, so do we have, is today our review day? Or?
No. Today is a teaching day. Next class will be a review, and then our test will be on Wednesday next week.
Okay.
We have like time for
Wait,
What do you mean?
today.
Oh yeah, this won't take long at all.
I won't be here. We won't be here next Wednesday.
Oh, you got your junior leadership nonsense?
Oh, we can push it back. We can push it back to like next month.
Do it Friday.
I'll figure it. It's only 2 people. We'll figure it out. Okay, so limiting reagents. What does the word reagent mean? Stop talking. A reagent is the same thing as a reactant. Reactants are found on what side of the reaction arrow? Left or right? Left. Right, so it's reactants react and form, what's the other thing called? Products. So in order for something to be a limiting reagent, it has to be on what side of the reaction arrow?
The left.
The left. So if you're ever asked to tell me what the limiting reagent is, if you're going to write something on the right side of the arrow, that can't be a reagent because it's a product. Okay, so what does the word limiting mean? Limiting means that it is what limits the amount of production of product. So in other words, the limiting reagent is the substance that runs out first. So it's your reactant or starting ingredient that runs out first. The reason that it's important to know what the limiting reagent is because that's what determines the maximum amount of product you can make. And so if one substance is going to run out first, that's going to dictate how much product can be made. Okay, so I'm going to give us a little example of this. Let's make a sandwich. Oh, you know what? Let's not make a sandwich. Let's make an ice cream sundae. Okay, so, or let's make an ice cream cone. Oh dear. Okay, here's my ice cream cone. That's my cone. How many cones do we need for our, finished product? We need 3 cones? Okay, I've seen that, where you have, all this ice cream, and then you've got, cones sticking out at the top. I've seen that before. All right, we'll say we need 3 cones. How many scoops do we need?
360.
Well, if we've got 3 cones,
So, 6.
8 scoops.
let's say we need 5. I think 8 might be a little excessive. Gravity is a thing, friends. So I'm not sure. I'm not sure what this. Okay, so what is this going to look like? Let's call this our. I don't know how to draw it. Let's call it our ice cream treat. Because it's not really a sundae if it's in a cone, right? Do we want any toppings?
Cherries.
A cherry? How many cherries?
2, 3.
82 sprinkles.
How many cherries? Did you say 2? Okay. Plus 2 cherries equals our 1 ice cream treat. Okay, so this is why the limiting reagent is important. Let us say that we have 32 cones and we have 48 scoops. What's the greatest number of ice cream treats you can make with these starting ingredients? Okay, so we would have to do stoichiometry. So 32 cones In order to make one treat, we need, what's the stoichiometric coefficient? Oh, Lord Jesus.
Scoops.
In front of the cones. 3. So 32 divided by 3 is a little bit less than 10, right? So that means we can make 9 full treats. Or a little bit less than 11. We can make 10 full treats.
A lot of treats.
Alright, it is a lot of treats. If we have 48 scoops, we can also do stoichiometry with the scoops. In order to make one treat, how many scoops do we need? In other words, what's the stoichiometric coefficient? 5. So 48 divided by 5 is less than 10, right? So 9 full treats. What's the greatest number of treats you can make from these two ingredients? You can only make 9. Because your scoops of ice cream are going to run out before your cones. Yes,
I
sir.
don't have any cherries.
Yeah.
We're not worried about the cherries for right now. We're just going to pretend like we have enough. Let's say we got a box of 100, so we're fine. Yikes. All right, so notice a couple of things. We chose the number that was smaller, even though it's asking for the greatest number, because we ran out of scoops before we ran out of cones. Did we add these two numbers together? No, that's nonsensical, right? Because you wouldn't say that that these are two separate entities. You're still making that one treat, and you need both of these ingredients to make the treat. So when you're asked a question like this on your homework, when we're using chemicals and real chemical equations, you'll choose the smallest number, and you will not add them together, because we didn't for the ice cream. So don't do it for chemicals as well. Okay, so now which one of these two starting reactants that we were given, the scoops or the cone, which one is the limiting reagent? The scoops. Because the scoops are what made the smaller amount. The scoop ran out before the cones did. So if you're asked a question, what is the limiting reagent? The answer is not 9 treats. The limiting reagent answer is scoops. Okay, so let's use your homework now to do these problems actually without ice cream. David, did you have a question?
No.
Okay. All right, so you have homework number 9 that you're looking at? Let's just start from the top and do number 1. What is the first step in any stoichiometry problem?
You want to find.
You want to balance them.
You want to balance that bitch.
I forgot about that. Back in my video.
Wait, are we on number 1?
We are on number 1.
It's balanced. That.
It is balanced.
You want to do. Put a 2 on it.
No, it's balanced. It's already balanced.
Put a 2 on it.
Don't put any 2s on it. It's balanced.
Oh.
All right, so now I'm going to read my problem. It says that an excess of sulfuric acid reacts with 150 grams of barium peroxide. That's this thing here. Oh. How many moles of H2O2 are produced if the other product is barium sulfate? Okay, so where does my moles, my question mark moles go?
By the BaSO4.
No, but thank you for guessing that. It says how many moles of H2O2. So
This is
question
right
mark
there.
moles goes here.
You just call me a. Okay, that's way too far.
Use the R word.
No, you just use the R word.
We do not,
You just call me a retard.
we do not use that word in this room. Plain ice, gentlemen. Okay, so what is compound A?
That one. The one you're about to point at. That one.
Yes, that's true. What's compound B?
The B.
H2O2.
That one.
H2O2.
Yeah.
Okay, so let's just solve this problem. Now,
Burn the cheeks.
the thing that makes this a limiting reagent problem is the fact that it says that your other compound is in excess. And so if you're not the limiting reagent, there will be leftovers. We call that being in excess. Okay, so let's just do stoichiometry. You're going to need the formula weight of barium sulfate. I don't know what barium is. 137.33 plus 32. 169.33 grams is your formula weight for, barium oxide. Now, it might have been a little bit since you've done stoichiometry if you didn't get to those lab questions. So remember the number on top of the second fraction, that's always 1 mole. Yep, so we said that B is H2O2, so what's little b?
Little b is 0, 1.
1.
You ever make it 1?
Have you done
What's little a?
1.
Good.
it? Word.
Now, here is a question where we're only looking for number of moles. So that means you don't need the fourth step.
Oh.
And so we're just going to solve it after this. So really 150 divided by
So like
169.33. What do you get for an answer?
hey, look at
0.3784.
I did not get that. I got 0.885.
Oh, well, I just generated that number from my head.
Yup. Confetti. She's like confetti.
What's the celebration about
You got
back
it
then?
right. You got it right.
Oh, well done. All right, so I only reported 0.88 here. That's because I only can have 2 significant figures. But I really should report that it's of H2O2. Oh, is my unit correct?
No.
What should it be?
Oh,
It should be moles. That's my bad. How do I know that it's moles? Well, firstly, my question asks for moles, so hopefully I did the right work. But my last unit in my stoichiometry is moles, so that's what your unit is.
that and then mole.
Yeah, it's moles of H2O2, not grams.
Stop calling me.
Okay, so this really is just a warm up for what we're going to do on the rest of these. And so it'll never be as easy as this again.
I don't think so.
All right, are you ready to move on to number 2?
Isn't this exactly wrong?
It is exactly what we were doing before. All right, number 2. Your first thing that you need to do is what do you need to do first?
Sulfur, so
Nothing,
A is
nothing.
sulfur.
It's all good.
It's check to see if it's balanced. It is balanced.
That's A.
Many of your equations on here already come balanced.
That's A and that's B. I know.
Numbers 7 and 8 are the only ones that are not balanced. So maybe go ahead and write that on there right away.
7, 8, not balanced.
7 and 8 are the ones that are not balanced. Okay, so I'm going to read my problem. It says a mixture of powdered iron, 10 grams, and 10 grams of sulfur is heated to its reaction temperature in an open crucible. How many grams of iron 3 sulfide, well that's a typo, it should be iron 2 sulfide, are formed? Okay, so what do I have? I've got 10 grams of iron. And I also have 10 grams of sulfur. What am I looking for? It says how many grams of iron 2.
So it has to be.
So this one has
Which
to
one's
be, this has to be B. But what's A?
S.
Yes,
Yeah.
Both of them.
both of them are A. So what do you have to do? You have to do the same thing that we did for the ice cream treat. You have to do stoichiometry not once, but twice. All right, so let's get this started. You know how to do this
I do it.
because you did it on your last homework. Did I hand? Yes, I handed them back. Our reaction is balanced, so we're good. This is a nice, easy problem to get started because there's no calculating for formula weight. The formula weight of iron is 55.84 grams. What goes on the top of this fraction?
1 mole. Oh, A.
Yep, and so in this case, A is Fe. What's the stoichiometric coefficient in front of compound B?
1.
Good. And the stoichiometric coefficient in front of iron is?
1.
Also 1. Okay, so now we do need to calculate the formula weight of that thing. 55.84 plus 32.06. Oh. 87.9, gentlemen, grams of FeS. What goes on the bottom of this fraction? Good. And then you should get an answer. How many significant figures should you have?
You should have 3.
Correct. So I got 15.7. My unit is grams of FeS. Now, I don't know if this is the right answer or not, so I can't circle anything. So I'm just going to leave that the way it is for now. And now I have to use the second A and do this whole process all over again.
It's the same liquid bullet.
So Jared, you're right. You're starting with the same
No.
mass. You should have 1 mole sulfur on the top of this fraction. The formula weight of sulfur is 32.06. B is still FeS. Stop.
It's 1.
And its stoichiometric coefficient is still 1. What's the stoichiometric coefficient in front of sulfur?
1.
Also 1. And then, always when you're doing these limiting reagent problems, your final step should be the same as the step before, if you're going to grams. And so I don't need to recalculate my formula weight for iron 2 sulfide because I already did that once before. So, I got 27.4 this time as my answer. Did you get that also? Can anyone confirm?
Yeah.
Are you just saying that?
No.
Okay. So now I have these 2 answers. I cannot leave my work like this. I have to choose one of the 2 answers.
I like the bottom one.
Okay, so we got some top, we got some bottom.
The top one. Be top.
Okay. Why would it be the top one? Because it's smaller. So, okay. So go back to what we learned about the ice cream treats. We chose the number 9 because those scoops ran out first. So what we're saying here is that
What is that?
how did that turn on by itself?
What was that?
It's there's a ventilation system that will pull the air from the room out to the roof.
Why does it do that?
Right on.
Maybe someone's on the roof.
So that's what it sounds like. I have it turned on when we do labs, but I had turned it off before because I don't need it anymore and it was noisy. But then it just turned itself on magically. That's really weird. Okay, so this is your answer. Now, you cannot know which one of the 2 is your limiting reagent unless you go through and do the whole process.
Why is it that the top one not?
Because your iron will run out. If you're mixing...
Oh, so whatever one's lowest.
Yes.
Okay.
Just in the same way that we ran out of the scoops before we ran out of cones.
That
So-
makes sense to me.
If we had an unlimited supply of iron, you could make this much grams of FES. If you had an unlimited supply of sulfur, this is the only thing you can make. So this one runs out first. Now, if you were to ask, or if your question were to say, which is the limiting reagent, this is not your answer. Limiting reagent equals the one that runs out first. And remember, it has to be something on the left side of the arrow, because reagents are reactants. Now, your question is not asking for this, but there are questions that will ask for that. Okay, so now you've got 2 of them done. There are 8 more problems like this. I will do 1 more of them with you. Which one would you like me to do?
7.
7? Okay. 7 is on page 3. The first thing you must do is...
Balance.
Thank you.
4.
All right, so balance that down up. So you're going to need a 4 here. And a 4 here.
4 there. Is that
Oh.
it?
And that's it.
Let's go.
Okay, so now I'm going to read my problem. It says a sample of 4.00 grams of methane. So I'm going to write it underneath that reactant. Is mixed with 15 grams of chlorine.
Oh my God.
Determine which is the limiting reagent. Okay, so in this problem, we're not asked to calculate a number of something of B. We're just asked to figure out which one's going to run out first. But in order to do stoichiometry, we need to have a B. So which B do you want to use?
That one.
Yeah,
The
that one.
one
This
that
one?
right there. Yep.
So you can choose what B is. Just make sure that B is the same for both stoichiometries. Otherwise, you're not comparing apples to apples, and that's a sad day. Okay, so then just do your stoichiometry. Do it twice. And then you have to decide which is the limiting reagent. So your answer is not a number.
You might not be wrong.
Your answer is a compound.
We have to do it twice again.
So how do you know that something is a limiting reagent problem? If you're given information about 2 reactants, that's how you know you have to do this twice. And that's true for always and forevermore. So 12 plus 4 is 16.05.
Yep, that sounds great.
So now it does not matter if you didn't want to choose CCl4 as your B, that's fine. You can choose the HCl, that's no problem. But then your math will be a little different than mine. What's the stoichiometric coefficient in front of CCl4?
1.
What's the stoichiometric coefficient in front of CH4?
1.
Also 1, good. The formula weight for CCl4, chlorine is 35.45. I get 153.81 grams of carbon tetrachloride. So then just do your math. I got 38.3 grams of CCl4. Can we do anything with that information?
Nope.
Not yet.
The other one.
No.
Okay, so then do the other one.
It's gonna be that one. I already know it.
I
think
just
so?
have a gut feeling it's gonna be that one.
Why do you think that?
Because 4, yeah, 4 is lower.
Okay.
So if we know that, do we even have to do that?
You do.
Oh.
You do. I'm hoping that you're wrong.
You're gonna be around.
I think you are wrong.
Are you sure?
I'm pretty sure. I'm pretty sure. Okay, so this is why you do have to do it, even though it looks like it's very tempting to say, oh, well, 4 is a smaller number than 15 by like kind of a lot. So why do we have to go through this? I'll show you why. 35.45 times 2 is 70.9. I'm still solving for B as a CCl4. Like that can't change. But now what's my stoichiometric coefficient in front of compound A here, which is
4.
Cl2, yes. Okay, so do you see this already? You have a greater denominator here because of a higher formula weight, and you have a greater denominator here because of the stoichiometric coefficient. So your denominator for your whole math is going to be considerably bigger, which means that the amount that you can produce is going to be quite a bit smaller, even though this number is the same. This isn't always the way, but how do you know unless you do the math? If there was an easier way than doing this twice, I promise I would tell you it.
Yes.
So I get for an answer
You should know.
8.14
You should know.
grams of CCl4. Do you see how much smaller that is? Even though you're starting with a smaller quantity?
Wow. Dominic, I can't see with your head in the way.
Is that CCL4?
It is. It is.
Yeah.
That's my best attempt at writing CCl4. So that
you're
means
wrong.
which one of these would be the greatest amount that you could produce?
Oh, the top.
The bottom one. No, if ever you're asked which one is the greatest amount, it's always the one that's smaller. Because you're going to run out of the chlorine gas before you run out of this. So that's not the answer you want though. So circling this is fine, but that's not what I'm looking for. I want to know who the limiting reagent is. So the limiting reagent equals, it's a compound, Cl2. So I'm going to go back and find who made the smallest amount. Who is my ice cream scoop?
Wait, so Miss Bishop, what was that answer?
I'm down.
The answer for number 7 is Cl2.
No, number 2.
Oh, the answer for number 2 is, somebody help me,
15 point.
15.7?
It was just that.
There we go. What are your
Yep, so you do have to read English. All right, we finished right at the time you guys are leaving. Great days.
Wait, do we have to?
Oops, I don't know what